Hello, my name is Pete Melrose, an independent information technology IT consultant to healthcare providers, and I appreciate your time and interest in this presentation of particular interest to professional and organizational healthcare providers entitled Handoff Communications. Isn't there an app for that? This presentation will familiarize you with the challenge of clinical information transfer in healthcare delivery venues and how the Cloud Healthcare Appliance Real-Time Solution as a Service, also known as CHARTSaaS, can be of potentially life-saving assistance. CHARTSaaS is designed for healthcare provider subject matter experts not having information technology, also known as IT experience, to create an IT application or app to automate the use case called handoff communications, which is the transfer of patient-specific clinical information from one clinician to another, typically orally, with reference to digital or handwritten notes. Thanks again for your time and attention. Quoting from an article in the September 2015 edition of Minority Nurse, quote, "Communication breakdown is the leading cause of medical errors such as gaps in healthcare, incomplete or missing information, and medication errors. So handoff reporting during shift change is a critical process that is crucial in protecting a patient's safety. Throughout the handoff report, it is vital to provide accurate, up-to-date, and pertinent information to the oncoming nurse. Not only are nurses transferring responsibility, but they also are shepherding and ensuring a safe passage for their patients." End quote. However, because of the complexity, confusion, and cacophony of the typical nursing station and healthcare delivery venues generally, as depicted in the photos, which lead to the root cause of medical mistakes, cognitive overload, the likelihood of a complete, accurate, and timely exchange of patient-specific clinical care information for each of the typically 25 or more patients on a current nursing unit census is low. Ironically, as denoted by the red box in the lower right photo, authoritative and current information is available via the computer terminal to the installed electronic health record or EHR system. But because the format and inquiry procedure typically are too cumbersome to be feasible during the thrice daily nursing staff shift change, nurses opt for oral communication based on incidental handwritten notes based on recall. Therefore, continuity of care is not assured and patient lives remain at risk. Since handoff communication errors are the leading cause of medical mistakes, they must be mitigated in order to reduce the resulting instances of patient morbidity and mortality. This schematic depicts a so-called sentinel event as reported to the Joint Commission per its accreditation requirements and published in the April 2015 issue of the Commission's publication named The Source as follows, quote, "A healthcare system submitted a root cause analysis, or RCA, to the Joint Commission for a sentinel event that involved a patient whose blood levels were not drawn frequently enough to monitor the thinness of her blood while receiving a continuous heparin infusion. The patient had been started on a heparin infusion on an orthopedic unit and then was later transferred to a cardiac unit. The order set for heparin infusion was not entered properly, leaving out the automatic order for blood tests every 6 hours. During the handoff report, the nurses did not discuss when the next blood test would occur to monitor a heparin infusion. For 24 hours, the patient went without blood tests until an oncoming nurse questioned the situation during the handoff report. At this time, the outgoing nurse also reported that the patient had been complaining of a headache for several hours. A computerized tomography or CT scan showed intracerebral hemorrhage. When the patient's mental status deteriorated, the family chose not to proceed with surgery due to the patient's multiple comorbidities and recent decrease in quality of life. She expired 3 days later. Although the organization had conducted a thorough RCA, the Joint Commission asked it to revise the RCA and to consider human factor issues that led to the event and to implement more strategies that incorporate human factor solutions, which would be more reliable to prevent the event from occurring again." End quote. Obviously, timeliness was the critical success factor in this episode. the fatal absence of which resulted from a handoff communications error. The right thing to do was ordered and was easy to execute, but staff cognitive overload created clinical confusion that allowed critical time to pass while the patient's biochemical bodily systems continued to function under increasingly adverse circumstances until they no longer could sustain the normal operation. The handoff communications use case is so problematic and so contributory to the occurrence of so many medical mistakes that it has been targeted by the Joint Commission, which is the USA accrediting agency for healthcare provider organizations, with the Commission's targeted solution tool for healthcare communications. The Joint Commission recommends mitigating handoff communication errors using its registered trademark Robust Process Improvement, or RPI, tools and methods, and also its registered Targeted Solution Tool, or TST version, targeting handoff communications. Quoting from the Joint Commission's Center for Transforming Healthcare website, quote, "The Center and its participating organizations use RPI methods and tools to improve the quality and safety of healthcare. These include Lean Six Sigma change management process and other change management methodologies and tools for high reliability," end quote. However, these tools and methods yield documentation and detailed training of process participants, thus creating more cognitive challenges and exacerbating the root cause of medical mistakes, cognitive overload. Handoff communications is the subject of one of about 15 so-called actionable patient safety solutions, or APSS, of the Patient Safety Movement Foundation, the aggregation of which is intended to help providers attain the Foundation's goal of zero avoidable patient deaths by the year 2020. The Foundation recommends handoff communication error mitigation using one of these APSSs, a multi-page document that includes an executive summary, performance gap, leadership plan, practice plan, technology plan, and solution specifics. This handoff communications APSS describes such communications in the context of several venues, including emergency admission, nursing unit shift change, and inpatient discharge. Also, it relies on various forms of the checklist heuristic to maximize complete, accurate, and timely communication. But, as with the Joint Commission approaches, the Foundation's medical mistake mitigation methods tend to exacerbate the root cause of medical mistakes, cognitive overload, by requiring memorization and rapid recall. However, and happily, this excerpt from the Foundation APS number 6 for Handoff Communications Technology Plan offers a breath of mistake mitigation fresh air by proposing the real-time or at least just-in-time application of information technology, or IT. Thus, the Foundation has distinguished itself in two ways vis-a-vis the Joint Commission. First, by proposing an IT mitigation method, which modality of process execution and cognitive support is distinct from the manual mode of documentation and training, as long ago discovered by other industries. And second, by identifying for guidance, but not necessarily recommendation, several specific IT solutions that apply. As shown in the second paragraph of the APSS number 6 excerpt depicted on this slide, the Foundation stipulates that, quote, "The technologies utilized should focus on ensuring that the point of handoff, all data critical to the care of the patient are communicated by the sender and are applied in real time by the receiver to ensure that required care is executed in an accurate and timely manner," end quote. Furthermore, according to the Foundation, the healthcare provider should, quote, "implement technologies that support the ability for clinicians to detail specific information regarding emergent or new onset conditions that may have occurred during the previous shift or in the previous care environment," end quote, and should, quote, "utilize a reliable IT platform that minimizes dependence on IT staff expertise, such as CHARTSaaS RA," end quote. Let us explore CHARTSaaS RA, the Cloud Healthcare Appliance Real-Time Solution as a Service reference architecture, in greater detail. The logo of the Cloud Healthcare Appliance Real-Time Solution as a Service, also known as CHARTSaaS, includes the staff of Asclepius, the Greek physician deified as the god of medicine, superimposed on a background of clouds. The intent of the logo is to represent an information technology or IT cloud-based solution that is compliant with the CHARTSaaS Integrated Development Environment reference architecture. A reference architecture being an IT specification of non-functional and functional requirements for components, configuration, and capabilities that can be used by medical practitioners and healthcare delivery professionals to create and operate applications, also known as apps, for real-time cognitive support. These apps, developed and used by healthcare provider subject matter experts, are expected to facilitate personal health management, to mitigate medical mistakes, to improve patient safety, to optimize case management and outcomes, and to accelerate the accrual and application of new medical knowledge as a function of the increasing use of CHARTSaaS by its credentialed professional and accredited organizational healthcare provider subscribers. Therefore, healthcare provider subject matter experts can create customized, cost-effective, and potentially life-saving apps such as handoff communications with little or no impact on subscriber IT system and staff resources. The flowchart shown here depicts the Sentinel event previously described as it might have occurred with a CHARTSaaS built app depicted in the green box in the bottom swim lane or row of the flowchart, running continually and designed to monitor the occurrence and content of updates to the EHR or HIS patient record and to report problematic events. In this case, the app would infer that the required blood viscosity or clotting test had not been performed within the required clock time interval from the previous test because the app could not detect the occurrence of an update to the patient's EHR case record test results data field. Therefore, the app would notify the clinical staff members via his, her, or their assigned stationary and/or mobile digital devices of the emergent need to perform the ordered test and to read the result, which the app also could do based upon event evaluation parameter values designated in the app process design. Thus, the medical error of omission would have been avoided and the patient's life saved. The remainder of this presentation describes the components and capabilities of a CHARTSaaS RA compliant solution currently in development and partially functional, and how it can be used by healthcare provider subject matter experts to create a handoff communications app with minimal IT support. An IT solution compliant with the CHARTSaaS reference architecture can automate processes that include real-time IT, staff, and system interaction in a customized and rules-based choreography as depicted in this schematic. Provider facilities and human resource icons are depicted above the flowchart, and IT system or application resources below the flowchart, and their real-time interaction is depicted in the rules-driven process flowchart. The digital and cloud-based characteristics of CHARTSaaS artifacts depicting knowledge as information structure in a functional context as an automated process will facilitate their sharing by the CHARTSaaS subscribers that created them, and thereby the improvement of medical practice and healthcare delivery globally. To create the handoff communication app, a licensed professional or accredited organizational healthcare provider must gain access to CHARTSaaS. The provider does so in 3 steps. First, surf to the CHARTSaaS.com website and use the secure portal to register as a CHARTSaaS subscriber by inputting the required credential validation, administrative, and payment data. Second, receive an email verifying subscription and including login credentials. And third, surf back to CHARTSaaS.com to log in and thereby obtain access to a private instance of CHARTSaaS to begin the design, development, deployment, operation, and optimization of the handoff communications or any other app. Here is the CHARTSaaS desktop, which mimics the Microsoft Windows desktop graphical user interface paradigm of several feature logos that all are available for use in no particular order. Observe that CHARTSaaS includes 12 features for app development and operation. Each feature is represented as a logo with a name and a brief supporting narrative. Each logo and name is an active link. Just left-click on any logo to display its supporting web page, which includes all of the functions needed to design, develop, deploy, operate, and optimize that feature. The included features are analytics, automation, case files, collaboration, events, things, information, interoperability, mobility, modeling, monitoring, optimization, and decision-making. In addition, note the log off, administration, and help links boxed in red on this screenshot at the top right corner of this and all CHARTSaaS website pages. In particular, the administration feature manages the credentials and assigned capabilities for all of the subscribers' authorized users. 4 of the 12 CHARTSaaS features will not be needed to create the handoff communications app, so I will describe them now. The analytics feature includes all of the functional components and capabilities included in the AURA auto relation analysis application, which is a virtually limitless capacity expert system for multivariate adaptive forecasting, created by Boris Zinchenko, PhD. The information feature is intended to make content, URLs, or internet links and other information resources readily available to CHARTSaaS users, either for reference in the creation and management of apps or for inclusion in apps for runtime execution. The monitoring feature is planned to include all of the functions of an industry-standard business activity monitoring or BAM solution, such as aggregation, analysis, and presentation of real-time information about app operation. The optimization feature will include functions that facilitate the redesign of app processes and included artifacts based on activity monitoring data generated by the monitoring feature and also by CHARTSaaS users and process actors. The 8 remaining features are required to create the handoff communications app, as defined by the red alphabetized boxes, the letters indicating the order of use, each of which will be described on a subsequent slide. Now let's use them to build the app. The CHARTSaaS modeling feature is the key feature of CHARTSaaS because it provides functions to design the app process, to include other artifacts created using other CHARTSaaS features in the process, and then to convert the app design time graphics to runtime code using software buttons. The modeling feature implements the flowchart paradigm to choreograph actions and the swim lane technique to assign the actions to included system and staff actors. Production-ready artifact versions, development versions, and obsolete production versions of processes all are cataloged by the modeling feature, in addition to which current production versions are cataloged by the automation feature to manage current production app library for deployment and operation. The actual flowchart describing the handoff communications process is shown in this slide, annotated with CHARTSaaS feature icons to locate where the process modeling, or A artifact, incorporates the other 7 feature artifacts in the app process. The D events things artifact being invoked at 3 locations and the F mobility artifact at 2 locations. Referring to the features boxed in red in the alphabetic order noted, 8 steps are required to create the handoff communications app as follows. A. Model or design the app process using the flowchart paradigm. B. Identify the source of digital case records or charts to be used, which is to say, the electronic health record system. C. Define the digital pathway and transaction or message content and format to enable interoperability with the digital charts. D. describe sources of data streams to be tested for occurrence of defined conditions, such as update of the charts. E, define the decision point included in the modeled process using the decision table paradigm. F, design mobile device user interfaces and operating characteristics. G, identify staff individuals and roles for authorized access to the app. And H, control launching of the app. This slide shows static representations of the three handoff communications app screens designed for mobile devices to effect sign-on, display of current patient roster on a specific nursing unit, and individual patient data formatted according to the Situation Background Assessment and Recommendation, or SBAR heuristic, where data that exceeds normal ranges or requires urgent action is formatted in red. Notice on the first screen on the left that once the user is logged on, he or she has the option to select a patient by name or medical record number, or alternatively, to select a nursing unit. If the nursing unit option is selected, then the system automatically creates a roster of patients currently residing on that unit with minimal demographic data to ensure positive identification. The user then selects one of the patients of interest, in this case Joan Baker, and the data for Joan are displayed in the format previously noted. In particular, the highlighted data in red here pick up on the critical data of the handoff communications example given earlier in this presentation, whereby the need for blood testing every 4 hours is noted and to discontinue the heparin as needed according to the order when particular blood test levels are attained. This screen set also is available for live demonstration on any Android operating system mobile device. This concludes my presentation of the handoff communications use case and its inherent medical mistake challenge with resulting and potentially fatal patient adverse event, and the recommended information technology or IT solution, an app created by a healthcare provider non-IT subject matter expert using a cloud-based integrated development environment compliant with the Cloud Healthcare Appliance Real-Time Solution as a Service reference architecture. Please contact me, Pete Melrose, via email at jpetermelrose@gmail.com or via phone at 001 US 612-201-2301 for further information. Thanks for your time and attention, and good wishes for another great day.